Let's head on to the first slide. Ay, may mga pumapasok pa. Okay, the important tool in laboratory. So one tool is the centrifuge. So the centrifuge is used to separate substances. So lalo na sa mga nakapag-intern na dyan. So yun, mas hands-on na kayo na nakakapag-operate ng centrifuge. And our centrifuge is disinfected every week ha. Weekly ang disinfection dapat ng centrifuge. Ayan na, naka-bold na, naka-highlight pa. And then we have two types of measurement when it comes to the revolutions and yung centrifugal force. So the first one is RPM, or the revolutions per minute. This indicates the speed of the centrifuge. And syempre, when it comes to the time or this unit, the revolutions per minute, syempre dapat nakakalibrate siya kailan naman? Every quarterly or every 3 months. Using what device? Anong ginagamit natin dito? Using tachometer with strobe light. Para saan yung strobe light? This is used to check the head angle. Okay. Ano naman yung kinaibahan niya sa relative centrifugal force? So yung RCF, it is the force needed to separate the components of a sample or solution. Ano pinagkaiba nilang dalawa? Yung RPM, yung pag-ikot lang mismo ng yung speed ng centrifuge. But for RCF naman, that is the force needed for the solutions or sample para mag-separate. And may isa pang term si RCF. Ano kaya sa tingin nyo yun, class? Let's have Miss Aliyah Maika. Please unmute. Hello, Miss Aliyah Maika. Are you here with me? Okay, hindi nag-unmute si Miss Aliyah. Okay, so the other term for RCF is sumasayaw ito, G-force. Okay, G-force. And nga pala, there is a formula for the RCF. So RCF, wait lang. RCF is equal to the RPM squared multiplied by 1.118 times 10 to the negative 5 times R. Ano kaya ang ibig sabihin ng R? That is the radius. Radius, which is in centimeters. Again, we have added information here. RCF, or the G-force, is equal to the RPM, or the revolutions per minute, squared times 1.118 times 10 to the negative 5 times the radius. Yung radius ay yung unit niya is centimeter. Okay, what about for the RPM naman? If you're going to find the RPM, so RPM is equal to the square root of the RCF. So RCF, okay, nakikita nyo pa ba? Divided by the quantity of, ano nga ulit yung R? Hello, ano nga ulit yung R?
Radius po.
The radius times 1.11. Wait lang, ulitin ko to ha. Magulo lang yung yung sulat. Pero please pa-copy ng RCF is equal to itong formula ng RCF. Pa-unmute naman nung yung may parang nagsa-sound yan. Thank you very much. Okay, nakopya na ba tong RCF? Para buburahin ko na to para mas malinaw yung RPM. Okay, sorry, nabura ko na. Okay. Okay, sige. So for RPM naman, RPM is equal to again, the square root, sorry, yan na yung pagkakasulat ko talaga. RCF divided by the quantity of the radius times 1.118. So yan, may quantitation dyan. Tapos kapag na-square nyo na yan, di ba syempre, ano ba yung uunahin yung isolve? Yung nasa pinakaloob. So si radius times 1.118. And then si RCF, you will divide it by the answer nito. And then you will get the square root. After you get the square root of that, so okay, pwede kayong gumamit ng calcu, times 1 times 10 to the 5th power naman. So, di ba, inverse lang sila nung RCF. Di ba yung sa 10, yung power niya is negative 5 dun sa RCF. And kapag RPM naman is 10 to the 5th, or yan, 10 to the 5th power. Tapos 10 to the negative 5th naman kay RCF. Okay? Ay, napakadami agad sa iisa lang na slide. Okay, next one. We have the types of centrifuge. The first one is the horizontal centrifuge. What is the other term? Naka-highlight naman dyan. Swinging bucket type. Ano daw ang itsura ni tubes kapag hindi gumagalaw or hindi na-operate si centrifuge? Naka-vertical position. And kapag in full motion, or nagsiswing na siya, di ba? Naka-horizontal position naman siya. And ano pang use ni horizontal centrifuge? It generates low speed but can produce tight pellet. Ano ba yung tight pellet? Yung pagkakapack ng precipitate or clotted cells in the bottom of the tubes. Okay, this is recommended kapag yung tubes natin is SST. What is SST? Phlebotomy. Serum, nandito na, serum separator tubes. Anong analytes ang hindi mo pwedeng gamitin or gamitan ng tubes with gel? Anyone? Kung sinong may alam? Or anong part or test sa chemistry in general? Yung hindi mo pwedeng gamitan ng gel kasi na-absorb siya. Therefore, it will cause falsely decreased or falsely low value. Saan siya? Kapag TDM. Ano yung TDM? What is TDM, everyone? Anyone?
Therapeutic drug monitoring.
Therapeutic drug monitoring. So, hindi mo pwedeng gamitin ang tubes with gel separator. Okay. So, this is the example of the horizontal sentry. Yan. So, kapag stable siya or hindi siya nag-ooperate, it is in, ano nga ulit position? Vertical. And then when it is in full motion, it is horizontal. Kasi itong horizontal centrifuge, for those of you who are not yet able to see or to operate this centrifuge, nagaano siya, nagsiswing siya. Kaya nga siya, swinging bucket type. Yan. Sa hospital na pinagtrabahuhan ko, yan yung mga centrifuge doon. So, share ko lang. So, yan, gumagalaw to. Pag stationary motion, so yan, nagagalaw yan. Okay. Oy, bakit another user to control? Ano yun? Huwag niyong pindutin yun. please, para hindi maputol yung ano natin, discussion. Yan, nawala tuloy. Wait lang. Okay, wait lang ha. Nawala. May nag-take control ng ano. Okay, so another type of horizontal sentry. Okay, we have the angle head centrifuge. What is the other term of angle head centrifuge? We have AKA fixed, nandiyan na din, fixed angle type of centrifuge. So ano yung angle niya? 25 to 52 degrees angle. So ang pinagkaiba niya kay horizontal centrifuge is that the sediments packs at an angle but not as tightly as with the horizontal centrifuge. So yun yung difference niya. And ano pa dito? Adequate for cell packing but decantation is not recommended. Bakit? Kasi nga, yung sediment na napack, angled din siya. So kapag dinicant mo siya, it is possible that some of the components here ay sasama pag na-decant mo na siya. Ano ba yung decant? Tatapon mo yung super natant. Okay, yes. Thank you. Thank you for the response. Okay, it produces less heat due to air friction during the centrifugation process as compared to the horizontal centri. So ito, commonly ginagamit din to sa clinical microscopy sa ibang lab. Yan, ganyan ang itsura. Yan, naka-angled na siya. Okay, yan. Kung makapapansin nyo, may mga conical tubes. Okay, the third one is the ultra centrifuge. Kaya nga, from the prefix ultra, it generates the highest speed. So it is held at a fixed angle. So pareho lang siya noong angle head, but generates tight sediment bottoms. Again, ang difference kay kay angle head is hindi siya kasing tight ang packing compared sa horizontal. Ito naman si ultracentrifuge, fixed angle siya but it generates tight sediment bottoms. Bakit? Kasi nga highest speed due to high speed generated. And kung high speed ang pinag-uusapan, syempre mas madaming power or energy ng centrifuge na nagagamit. That's why it is refrigerated to reduce the heat built up produced by the friction kasi nga sobrang bilis. And this is recommended for lipoprotein separation. Okay, let's call para masaya naman tayo dito. I'll be calling names para hindi lang ako yung nagsasalita. Miss Hannah May Amores. Please unmute. O naman ha. Mag-participate kayo, hindi yung ako lang nang ako nagsasalita. Sino ang tinawag ko? Sorry. Nakalimutan. Hannah May. Hello, Hannah May.
Hello po.
Okay, from what you have studied in your lower years, what are the types of lipoproteins that you can remember?
Hello po rin. Rinig po ako.
Yes, you are audible.
Sa natatandaan ko po, ang types po ng lipoprotein are the mga low density lipoprotein, the high density lipoprotein.
Lipoprotein?
Ay, lipoprotein po.
Yes,
and
yes.
the very low po.
Very low. And the
Chylomicrons po.
Okay, thank you very much for answering. Chylomicrons, you can now mute. Thank you. Okay, So yung ating mga lipoproteins for review, so yung chylomicrons natin, very low density lipoprotein, the low density and the high density. Sa tingin nyo, ano yung pinaka nagpapak sa ilalim? Dun sa mga nabanggit natin. You can answer in random. Siyempre, kaya nga high density, di ba? High density. Bakit sa tingin nyo, this has the, among these lipoprotein, siya yung may pinakamadaming, anong content kaya yon? Letter P.
Protein po.
Protein content. Okay. So again, sino dito yung nagta-transport ng exogenous triglycerides? Dito, sa mga lipoproteins na to. May nakakatanda ba?
Low density.
What is the answer? Anong sagot?
Low density lipoprotein po.
Ano itong binibilugan ko?
Chylomicrons.
Chylomicrons. Ang palatandaan ko dyan dati, Kaya nga exogenous, parang pagkakaspelling ko dyan dati, exogenous. So chylomicrons. What about endogenous? O review na lang to. Endogenous triglyceride.
Very low density. VLDL po.
VLDL. Ang palatandaan ko naman dyan dati, since ako si Vian, na lagi akong nasa loob lang ng bahay, so endogenous. So, yan, napakaraming terms ang kailangan nyong i-memorize. You have to find ways para matandaan sila. You make fun with the words. Yun, if that's how you can understand the concepts, please do. Okay, next. So yan, napakalaki ng ultracentrifuge kasi nga siya ay ultra. Okay, let's move on to the glasswares. What is the most commonly used glassware in the laboratory? It is borosilicate. Ang example nito si Pyrex and Kymax. Di ba si Pyrex, hindi lang naman yan sa lab, di ba? Kahit naman sa mga Tupperware ng inyong inay at ng inyong mga magulang yan, may Pyrex. Okay, so that is most commonly used. That is for sterilization and heating. So ang resistance ni Pyrex is, Pyrex pala, hindi Pyrex, 515 degrees Celsius. Okay, for boron-free glassware or soft glass, it has high alkali resistance. So kapag mas concentrated yung basic solutions or mataas yung alkali content of a chemical, you can use boron-free glassware. And it has less thermal resistance than the borosilicate one. And the third one is Corex naman. Corex is a type of aluminosilicate glass. It is strengthened chemically rather than thermally. Kaya nga C. Strengthened chemically, Corex, C. Yan. It is 6 times, C ulit, 6 times stronger than borosilicate. C, Corex. Okay, next one. Vicor. Okay, so si Vicor, ito naman with high thermal resistance. So pareho silang branding. So si Corning for Corex and Vicor. So ibig sabihin parehong may ganyang glass si Corning na brand or what not. Okay. So this is for drastic. Ano ba pag sinabing drastic? Biglaan, kaya nga heat shock. And extreme chemical treatment. Yan, may exception tayo. The hydrofluoric chemical and dilute alkali. Si Vicor naman, si Vicor is with Vigor. Parang wala tandaan ko dati. Yan, high thermal resistance. Kasi nga, malakas yung resistance niya. So may Vigor siya. Ganyan. Tapos, for flint glass, this is made up of soda lime. So ito medyo, mahinang klase, no? Easily melts due to low thermal resistance. Kasi nga, lang siya, panapon. disposable glasswares. Okay, next. Ito naman, mga pipettes. So, according to calibration marks or design, we have two types. We have the to deliver, which is TD, and to contain, TC naman. So, napakadaling tandaan, TD, TC. Kapag sinabing TD, it delivers, kaya nga to deliver, exact amount that it holds into a container. And it requires no rinsing. Kasi nga naman, kapag na-deliver na yung exact amount, edi hindi mo na siya kailangang i-rinse. Ano ba yung tinatawag na rinsing ha? Baka kayo ay malilito kasi may mga rinsing na terms that we are going to mention later on. So, di ba kunyari, this is your pipette. Pagpasensyahan ang drawing ni ma'am. Okay, kunyari yan yung pipette. Pag sinabing rinsing, kunyari, this is the amount of the solution that you have aspirated and you're going to dispense it. When you dispense it, parang iaano mo pa siya, i-operate mo ng paulit-ulit yung aspirator para lang lumabas yung laman dito. Gets nyo ba? Kunyari, you will mix it with another solution. So, kunyari, ito yung sa pang solution. So, i-dispense mo yung laman ni pipette, i-rinse mo siya para makuha mo yung total na laman sa loob para mahalo siya. Yun, sana na-gets nila. Okay. So, yun yung to deliver. Kapag to deliver, it doesn't require rinsing. So, sakto na. Okay, for contain naman, to contain, it holds particular volume but does not dispense the exact volume. Kaya, it requires, yun, yung sinasabi ko kaninang rinsing. Parang ano lang yan, parang ito, biglaan ko lang naisip kanina, I don't care kung makornihan kayo. So kapag kunyari sa delivery, no, pag may dinideliver na parcel sa inyo, dapat exact address yung mapupuntahan. And kapag yung contain, parang sa mga container vans or container, yung mga vehicles, di ba? So, sama-sama na sila lahat doon, yung mga parcel, kaya, ayun, hindi exact yung volume. Kailangan pang i-deliver para maging exact. I don't know if you get the similarity or ano, basta yun. Kung gusto niyo ng clue para hindi na malito. Okay, kung wala, edi discard niyo na yan. Okay, for types according to drainage characteristics. So, one is blown out. Isa pang corning joke dito sa blown out. Naisip lang namin ni Ma'am Jess kahapon. Sorry, Ma'am Jess, dinamay kita. Okay, for blown out, it has continuous etched rings or colored rings on top of the pipette and the last drop is blown out. Paano ba kayo nagbo-blow? Anong sound yung na-produce nyo? Letter H. Okay, blow out has a continuous etched rings. Okay, may naghaha-emoji. Thank you naman, natawa kayo doon. Okay, the exact volume is obtained if the last drop is blown out. Ayan na, hindi nyo na makakalimutan, di ba? Kahit ang corny-corny ni ma'am. Di yan. Okay na. The second one is self-draining. Kaya nga self-draining, it drains by gravity. Hindi mo na kailangang pilitin, kusang nagde-drain. And syempre, wala siyang etch. Kasi nga, hindi mo siya blinow. Okay, para lang tayo ditong Okay, sana natatandaan nyo. Next, yan na, si H. Yan si H. Again, kapag may H, blown out pipette. Okay, next one, according to purpose. So, graduated or measuring pipettes. Kahapon, nag-iisip talaga ako paano ba natin ito matatandaan. Sorry, kayo na lang ang mag-isip nito. So, for serologic pipette, the graduations are up to the tip. So, isa pa siyang blown out pipette. Again, pag blown out pipette, may etched rings. Okay. And tandaan nyo ha, ang ating mga pipettes, syempre sa mga matagal na din panahon, hindi tayo gumagamit ng pipetting by mouth. So, dati pang era ito. Okay. So, for the more pipette naman, more without graduations to the tip. Sinong umabot hanggang dulo? Si Zero. Serologic pipette. Bakit? Kasi, ayun. Okay, calibrated naman between 2 marks, si more pipette. The tip should not be allowed to touch the vessel and it is self-draining. Again, kapag self-draining, it doesn't require blowing. Kaya nga siya may kusa kasi nga may gravity. Okay. For the fourth one is bacteriologic, ball, Colmer, and Kahn pipette. And the fourth one is the micropipettes natin. Ano yung TC? Again, what is TC?
Contain.
To contain. So if it's to contain, it does not dispense the exact volume. Okay, like for example, this one, less than 1 ml na yung liquid. Anong examples niyan? Si Sally Hillige na encounter ninyo sa hematology nung kayo ay third year Hema 1? For anong method kaya ito? Kung natatandaan ninyo. Si Sally Hillige. Saan kayang method of hemoglobin determination yun? Anyone? Kung sino man? Sa acid? Acid?
Hematine.
Hematine. Very good. Okay. Sa acid hematine, di ba, yung hemoglobin combines with the 0.1 normal HCl and thereby it produces a yellowish-brown pigment that you call acid hematine. And other types of it are Lang-Levy, RBC, and WBC pipette. Yes, you are familiar with that. So Thoma pipette, Kirk, and overflow pipette. Next. Okay, ang ating transfer pipette. Ang ating transfer pipette, we have two types, the volumetric and the Ostwald Paulin. Okay. Since it is volumetric, ito, tatandaan nyo, self-draining. Ang ano ko dyan is blown out is OS, si Oswald, and si serologic. Self-draining is si volumetric and si more pipette. Okay, for volumetric pipette, this usually has the highest degree of accuracy and precision. Kasi nga, volumetric na siya. And then for Ostwald Paulin, so viscous. Viscous fluid naman. Ito ha, huwag niyong pagsasamahin ang dalawang V sa sabog. Kaya volumetric, hindi siya viscous ha. It is non-viscous. And for Ostwald Paulin, this is the one for viscous fluid. And yung Ostwald Paulin natin, it has a bulb-like enlargement of the pipette stem. We can see the picture. Ito yung sinasabing bulb-like enlargement natin. Okay, kung nakikita nyo dito, pareho silang may etch. At kapag may etch, sila ay, anong klaseng pipette? Blown out pipette. Okay, like for this one, humabot hanggang dulo, ang graduation or nakagraduate hanggang dulo si serologic. Pero kung sino yung, ayan, yung isa, sino nga yung isang hindi umabot sa dulo, ang graduation? Si Moore. Moore pipette. Okay. Okay, another samples of pipettes. Okay, and si Pasteur pipette, or also known as medicine dropper. Okay, let's go to the automated or automatic / mechanical pipette. So the most commonly used na nakikita ninyo sa laboratory is the air displacement pipette. Para saan yung part na piston? This is for the suction. And ano yung mga nakikita natin na mga naka-box, 'di ba, na may yellow and blue? Ang tawag doon yung pipette tips or the disposable tip. And the disposable tip or yung plastic pipette tips, it is made up of polypropylene. Yun yung pagka-plastic niya. Okay, the second one, positive displacement. It is much like a hypodermic needle. So we have pictures of that. Wait lang, may mga pumapasok pa sa meeting. Okay, for positive displacement, it operates by moving the piston in the pipette/barrel. So it does not require a tip unlike the air displacement pipette, but it requires recalibration. Ano yung ginagamit dito? Letter C. Capillary. Okay. For the third one, dispenser or dilutor pipette, from the term itself, it obtains liquid from a common reservoir and dispensed repeatedly. So, dual purpose siya, sampling and dispensing functions for dispenser or dilutor pipette. Okay, ito yung difference ng dalawa, yung air displacement and the positive displacement. So dito sa air displacement, we have the piston, the shaft, and the tip. So ito yung disposable tip natin. And for positive displacement, yung piston niya is here, dito sa gitna. And then it has disposable capillary. It has also a shaft and a piston seal. Yun yung pinagkaiba ng air displacement and positive displacement pipette. Okay. Again, this is for air displacement, and this is for positive displacement pipette. Okay, must know, nabanggit na natin, the plastic pipettes are made up of polypropylene. For the calibrating media, for the pipettes na may TD na sign or to deliver distilled water. And for to contain pipettes, ang ginagamit na calibrating media is mercury. Okay, let's move on to cleaning of glasswares. So lalo na kapag mga ginamit, of course, sa laboratory, so you have to pre-soak in soapy water. So bababad mo muna sa masabon na tubig and then use acid dichromate for cleaning or potassium dichromate dissolved in sulfuric or nitric acid. And you should rinse it with type 1 or type 2 water. O reviewin nga natin yung mga types of mga reagent water natin. For type 1, sa tingin nyo, ano yung pinaka-pure dito sa tatlo? Anong pinaka-pure na water?
Type 1.
Type 1.
Type 1 po.
Okay. The type 1 water, it has the maximum water purity. Saan siya ginagamit? Ito, for procedures like HPLC, electrophoresis, sa toxicology, And yung ating mga standards or yung mga buffers natin nakasama sa reagent, 'di ba? Sa mga reagent kits and yung mga controls. So kailangan type 1 water. This is the one ideal na dapat gamitin for these types of tests and solutions. For type 2 water naman, this is the water used for si CHIM. Sino si CHIM? For chemistry, hematology, immunology, and microbiology. Type 2, CHIM. And then sa type 3 naman, ito yung for, ito na yung panglinis, yung pang-washing, pang-rinsing, or yung mga panghugas ng tubes, ito na yung type 3 water. Okay. And for sterilization naman, using the dry heat oven, okay, ilalagay mo siya sa dry heat oven with a temperature of 160 to 180 degrees Celsius for 1.5 hour to 2 hours. Ano to ha? Degrees Celsius. Okay, let's go to instrumentation. Under photometry, we have spectrophotometry and fluorometry. Ito yung mga pinaka-importanteng instrumentation na ginagamit sa clinical chemistry. Okay, from the basic term photometry, this is the general description for the measurement, kaya nga metry, photo, light, measurement of light. Definition of terms naman, light, it is a form of electromagnetic energy that travels in waves. Travels in waves. And for wavelength naman, this is the distance between the peaks of a light wave. So kung i-illustrate natin yan. Okay, so for example, this is the wave, no? What do you call to the top part? Anong tawag dito? Review.
Crest po.
This is the
Peak
Po.
peak.
Peak po.
po.
Okay, what about the lowest? This is the
Throw po.
throw. What about the distance between these two waves? Anong tawag dyan?
Wavelength.
This is the wavelength. What about the height from the peak to the throw?
Amplitude po.
Letter A is
Amplitude.
amplitude. Okay, note that the wavelength is inversely proportional to the amount of energy. So kung mas mataas yung wavelength, mas mababa yung amount of energy. As simple as that. Inversely proportional. Okay, for ultraviolet light naman, di ba we have the visible light range? Ano yung visible light range natin? Na nakikita ng ating mata? It is 400 to 700 nanometers. Kapag less than 400, you term the light as UV. Okay, paano ko ba dati ito tinatandaan? Yung 4 kasi mukha siyang payong. Kasi 'di ba kapag against yung payong, syempre piniprevent yung UV light. So kaya yan, kaya natandaan ko siya. So less than 400 nanometers, so that is ultraviolet light. And then for more than 700 naman, so yan, 700 infrared light. Okay, so ito yung wavelength for violet, blue, green, blue. Kung pwede nyo din naman yung tawag nito, i-notes. Okay. For spectrophotometer, it is the measurement of light intensity in a narrower wavelength. So, review lang ulit tayo ng components ng spectro. So, the first one is the light source. From the word itself, it is the continuous spectrum of light, or this is the one providing polychromatic light. Okay, the most commonly used light source is the tungsten lamp. Hanggang 1,200 nanometers ang kaya niyang i-detect. And then for visible, yun yung visible infrared range. Ayan, pwede si tungsten halogen, tungsten iodide, and immersed glower. For UV range naman, we have MDX, mercury arc lamp, deuterium, and xenon arc lamp. Kapag quartz halogen, ano kaya siya for, hulaan nyo na lang, UV or infrared? Okay, for quartz halogen lamp, it's for infrared. For infrared light. Okay, next. So this is the basic instrumentation ng ating spectro. So ito yung light source natin. Yung collimator kasi, alam ko, iba yun sa entrance, tawag nito, sa entrance slit. Basta iba siya. Yung collimator, may mga spectro na collimator yung nandito. Yung iba naman, entrance slit. So ano ba yung function ng collimator? Anyway, this is just nice to know, sorry. So yung collimator, its main function is to stop all the non-perpendicular photons from striking the light or the crystal. Okay, ang main purpose niya din is to change the diverging light or other radiation from the point source into a parallel beam. Okay, so yung entrance slit naman, as a review, anong ginagawa ni entrance slit? It minimizes. Ano minimize niya? Stray light. And then what about the monochromator? Para sa ng monochromator?
Isolation.
Isolates specific or individual wavelengths. And then yung exit slit. Para sa ng exit slit, it controls the width of the light beam. What do you call the width? Ito yung band pass. Ayun, nasabi ko na pala. So yung band pass, that is the width of the light beam. And then itong photodetector cell naman, review, it converts, ano kino-convert niya? Yung light, syempre nag-pass through dito, di ba? It converts the light to electrical
energy.
output or electrical energy. And then yung nakikita nyo yung display, that is the galvanometer or the readout device. Okay, itong I.O. dito, anong ibig sabihin nito? That is the pamula sa exit slit, ano yung tawag sa light na nag-pass through? Ano to? Incident light. And then, kapag nag-pass through naman dito, or yung band pass, bago pumunta or bago siya ma-detect ni photocell or photodetector, ano tong eye na to? Anong tawag dyan? This is the
Transmitter.
transmitted light. Okay. So yan na, sinummarize na natin. So for entrance slit, it minimizes stray light or yung unwanted light. Okay. Paano mo ma-remedy ang stray light? You will have to use a sharp cutoff filter. Okay. For monochromator naman, it isolates specific or individual wavelengths. We have 1, 2, 3, 4 types of monochromators. So the first one is the prism. So it may be glass, quartz, or sodium chloride. Okay, from my notes, yung prism, it produces pure light. And then yung most commonly used naman natin is diffraction gratings. So mas maganda to kaysa kay prism. It has better resolution. And then for filters naman, it is used by photometers. And then yung holographic grating. So ang pinakamahalaga naman dyan si diffraction grating. And how do you remedy the stray light? You use a sharp cutoff filter or a filter. Next. Ayan, exit slit, it controls the width of the light beam. So natakalan natin kanina. And the bandpass is the total range of wavelength transmitted. Kaya nga after nang nag-pass through sa cuvette, di ba ito yung bandpass, ano na yung tawag na light? Transmitted light. And then for sample cuvette naman, ano yung other terms niya? Absorption cell, sample cell, or analytical cell. Okay, it holds the sample solution whose concentration is to be measured. So, dun mo nilalagay yung iyong analyte. Okay, for aluminosilicate glass, again, this is the most commonly used sample cuvette. And for quartz or plastic, this is for measurement of solution requiring yung visible and UV spectra. Okay, photodetector. Again, it converts the transmitted light into photoelectric energy or electrical output. So we have two types of the photodetector. We have the barrier layer cell or the photocell or the photovoltaic cell. It is the simplest and least expensive. Sino naman yung most sensitive na photodetector and most commonly used? Si PMT, si photo multiplier tube. May isa pang term kay barrier layer cell. Let's add selenide. Selenide cell. So, nice to know din. So again, si photomultiplier tube, it is most common